I am your guest speaker today. I'll be introducing myself. I think everyone knows who I am, Michael Mateas. I direct the Center for Games and Playable Media here at UC Santa Cruz. I'm the founder and co-director of the Expressive Intelligence Studio, which is a large game AI research group on campus, and I'm one of the founders of the undergraduate game design degree. Today, what I'm going to be talking to you about is this Photoshop of AI debate that a couple of years ago was a big debate within the commercial game AI community. So what is this Photoshop of AI? It starts with a talk that Chris Hecker gave at GDC, I believe in 2008, talking about what he called the structure style decomposition. So these first few slides are actually going to be slides from Chris Hecker's talk, where he sort of sets up this idea of the Photoshop of AI. So he asked an interesting question: what technology has had the most profound impact on games? So anyone have some ideas to throw out of the most profound impact? Yeah. Computers. Okay. How about which computer technology? Graphics cards. Okay. The internet. All right. Reading. All right. Here's what Chris says. All right. One more. Artificial intelligence. Oh, I wish it had. All right. So he says what's had the most profound impact on games is the texture mapped triangle. That's basically the foundation for 3D computer graphics. And that the texture mapped triangle, if you sort of look at the evolution of games over the last 20 years, and you were just to play a game for like 10 seconds and just sort of look at it, that this would be the single most visible indicator of progress you would see in games. And what's so cool about the texture map triangle, right? As a primitive in 3D computer graphics. Chris says that what's so cool about it is it allows you to decompose aesthetic concerns. That you can sort of take, here's the sort of math part of the problem, right? The kind of formal structural part where you have to write algorithms that know how to manipulate this thing and render it on the screen. And here's the aesthetic part of it, where an artist is coming in and trying to make something that has a specific look and feel, and you can combine those two things together and get a 3D object that has both a style and a structure that the computer can manipulate. And it's those two things together that gave us games like Doom and Quake, right? And sort of every 3D game in the last couple of decades. That ability to take the humble, simple triangle and then combine it with artist-produced textures allows you to create kind of richly realized environments. And this structure versus style decomposition, Chris claims, and I think it's a really interesting claim, is found everywhere that hard interactive problems are being solved. That the only way to sort of make forward progress on hard interactive problems is to find some underlying fundamental structure that the computer knows how to represent and reason about and manipulate, and figure out some way to overlay on top of that structure kind of aesthetic style that can come from artists. And unless you can find that structure and stylistic overlay decomposition, you can't solve these hard interactive problems. And what makes a problem hard and interactive? Well, it's this perfect storm of technology, aesthetics, and interactivity. That there's like a hard technology problem you're trying to solve. It also has to be highly interactive, and it has to actually convey a style, right? It has to convey, it actually has to function as art. And that when you combine those three things together, you've got one of these really hard interactive problems on your hands, and that the only way forward is to find this decomposition. And that's why graphics, if we look at the progression of, say, just screenshots of games over the last 10 years, you see this just huge progression in kind of visual fidelity and style over those 10 years, right? You see a lot of very visual progress in graphics. And the reason we see that very visual progress is because they found their structure style decomposition. It's the texture map triangle. And that other areas of game technology that haven't found that decomposition, you haven't seen that progress. So he claims that solutions to hard interactive problems will always have a deep structure versus style decomposition. So what are some other examples of structure versus style decompositions? Well, animation certainly has that, where you have the sort of underlying structure of the 3D models and how they articulate and the limits on their articulation and so on. And then animation data comes in, and the animation data allows you to communicate a specific style or aesthetic quality of motion. Similarly, fonts and sort of Bezier curves and other kinds of interpolated curves allow you to take a few points which are specified by a font artist and turn those into a smoothly, infinitely scalable font that the computer knows how to manipulate. Waveforms and sort of waveform synthesis and waveform combination is another place where we know how to sort of reason about the underlying structure of waveforms, and then when you give me different waveforms, that's where an artist can input aesthetic style. So which technology should have had the most impact on games? Yay! AI. And has it had this huge impact? No. We've seen over the last, if you looked at sort of screenshots of games over 10 years, you see this big graphics progress. If you play the games and say the level of NPC interaction you have with the characters, not a lot's changed in 10 years. So one making a lot of progress, the other not making a lot of progress. And Chris's claim is that we won't be able to make that progress until we have a structure-style decomposition. And how do you know when you've got a structure-style decomposition for a problem on your hands? When there are art tools available to artists who can author style and just superimpose it on the structure, right? So with the texture map polygon, we have that art tool, right? Photoshop. An artist can work with Photoshop. They don't have to know anything about the underlying guts of how 3D computer graphics works. They don't have to have taken a bunch of linear algebra courses, none of that. They can work in Photoshop, make beautiful textures, boom, their style gets overlaid on the structure, and voila, you have beautiful game worlds. So Chris claims we will not solve the AI problem in games until we have a Photoshop of AI. And this created a lot of consternation in the game AI community. A Photoshop of AI, what the heck would that look like? Is it even possible? And this ended up being debated at the AI Summit at GDC a year after Chris's talk. And here we see a number of AI luminaries at the table sort of arguing about, is the notion of a Photoshop of AI possible? How would you make progress towards it? This was followed up with by Damian Isla, who was one of the people in that debate, Photoshop of AI debate, at a further talk at the Foundations of Digital Games, where he kind of posed it as this fork in the road between kind of two divergent points of view. One he attributes to me, and then one he attributes to Chris. So what he attributes to me, which it's a fair attribution, is that the way forward is that we need a new breed of engineering competent designers or design sensitive engineers, right? That game AI progress is going to be made by programmer artists who know how to deeply reason about code and architecture and understand behavior. And that the other way forward is, no, we need better authoring paradigms. We need a Photoshop of AI that allows people who don't have all that technical skill to somehow magically author rich behaviors for games. So here's a screenshot from the current state of AI authoring. This is something that Damian shared in his talk. So typical AI authoring tools you find today look like things with like a zillion checkboxes and a bunch of different text fields where you put in magical numbers, and fields like this one, Jamie, don't touch this ever. Right? So this is pretty much the current state of AI authoring tools, is that there are these these very complex, sensitive beasts that you need to have a lot of skill to be able to use appropriately. So this certainly doesn't feel like a Photoshop, right? So This is a talk I gave a year or two ago now, where I kind of came in and said, okay, people keep on invoking my name in this debate, right? Like Damian did. So let me just give a talk that actually stakes my position in the ground. And my position is that there will not be a Photoshop of AI, that is a mirage. It's the desert image, in case people were wondering. The Photoshop of AI is sort of this clever concept that kind of tricks your brain into thinking it's possible, but as soon as you kind of dive down and analyze it, any right-thinking individual would be forced to agree that no, that is not the way forward for game AI. That it inherently requires sort of an integration of structure and style combined richly together that doesn't allow you to separate them out into this sort of pure style tool and a structure tool. More specifically, the Photoshop of AI concept grossly underestimates the size of the AI problem. That the AI problem is actually much bigger than the graphics problem. Second, that it overestimates the intuitiveness of visual art production. You know, Photoshop's been put up here as this sort of easy-to-use tool that anyone could pick up, right, and make beautiful art with. Well, let's dive into that a little bit and see how easy to use Photoshop is, even for visual art production. And finally, and this one's a little weird, but I think it'll make sense when you get to it, that it doesn't take seriously the property of conditional execution. That game AI is fundamentally about making decisions and making them differently depending on what's going on in the world. And that property of conditional execution is fundamentally different than any of the structure style examples Chris previously gave. It's different from waveforms, it's different from fonts, it's different from animation, and it's different from texture map triangles. And that difference makes a profound difference in what kind of tools you can create. However, what I did really like about this debate coming up is it does usefully highlight the authoring problem in AI. AI is authoring, right? AI is content. And sometimes that has been overlooked or not appropriately appreciated, that people who are creating the AIs for games are doing content authoring. And so it's good for us to think hard about the best ways to do that kind of authoring. So first of all, now we'll just sort of march through these points. Chris kind of sets up this structure style decomposition thing with graphics and AI as equals, right? So he has sort of, representing 3D space as the hard interactive problem. And boom, we nail it, we crush it with this structure style decomposition. So now AI, a similarly sized problem, right, needs, here we have question marks. We need to find its structure style decomposition. Well, let's see, first of all, if AI and representing 3D space are actually problems of a similar size, right? Because if they're not, if AI is like a much bigger, harder problem, then we're not going to be able to find as easily like a single structure style decomposition that just crushes the AI problem in the same way that triangles and textures do representing 3D space. So let's look at the problem of representing 3D spaces across a bunch of games, right? Here we see a game and we need to represent 3D objects in space with different sort of textures that represent different physical properties, right? Here we need to represent, 3D objects in space that you can move around in with textures representing different physical properties. And here we have to do it again, right? Oh, and we need to do it again, right? So this is all across these different screenshots, the same fundamental problem is being solved over and over again. Now let's look at the problem of game AI across a number of games. Well, maybe your problem is creating non-player characters that have rich sensory systems that actually model like hearing things and seeing things so that you can make stealth gameplay, right? So in a game like Thief, the stealth gameplay is completely enabled by an AI that has the ability to kind of reason about sensory perception. And if you didn't have that AI that can reason about sensory perception, you don't get to have stealth gameplay, right? So in that case, the AI and the gameplay it enables are completely intertwined. Or maybe you're making NPCs that play American football, right? And those NPCs, that's not about deep and rich modeling of perception and reactions to perception. This, much of the AI here is actually about the lower level AI that drives body movement, right? So first you have to have sort of higher level AI that knows about plays and can carry out plays. And so that's sort of multi-NPC coordination. But a lot of effort in, say, Madden football is put into really complex procedural animation systems that can take lots and lots of animation data and combine it together on the fly to make really cool tackles happen, right? And really cool physical movement happen that's actually driven by like the physics of what's going on in football. And that's part of the lower level AI of these NPCs. And notice this problem doesn't look anything like the thief problem. And neither of these look anything like characters, say, in Codor that you're having conversations with. Right? And how do you sort of model conversations and conversation progression and what topics have been brought up in the past and how those topics influence which choices the player is presented with and the conversation trees and so forth. Again, like a completely different AI problem. Or maybe you want to have characters that learn from watching the player. So here we see an avatar in black and white, the cow avatar, that's learning to perform actions in the world by doing things in the world and then being rewarded or punished by the player for doing those things. And over time, it learns how to autonomously carry out the wishes of the player. So it's doing learning. That looks completely different again from any of the previous AI examples we've seen. Or maybe you're about dynamic pacing and dynamic difficulty adjustment, like the AI director in Left 4 Dead. So in this case, it's not about controlling NPCs at all. It's about changing the spawns and dynamically kind of controlling the spawns in the world so as to create a particular tension arc for the experience. Or maybe you're modeling complex city dynamics, like in SimCity, in which case you're using cellular automata models, a completely different kind of AI, again, to model how neighborhoods evolve over time as a function of what's going on in other neighborhoods. Or maybe you're modeling common sense reasoning, like in Scribblenauts, where I write a word and it drops an object into the world, and that object has to be able to kind of figure out, based on its properties, what it does and doesn't do in this particular setting in the world. And so a ton of objects had to be represented to the machine with their properties and the kinds of actions they can take in a way that the system can figure out how to kind of mix and match them no matter what objects the player drops into the scene. So another kind of AI having nothing to do with NPCs. So wow, well and I could go on all day with examples of completely different things going on in games that are AI. So compared to the graphic screenshot where it's like the problem of representing objects in 3D space kind of over and over and over again in every game, right? Here, the situation we see doesn't look like this at all. It really looks like this. So there's this teeny little problem over here in the corner, representing 3D space. And someone found a structure style decomposition that's really useful for solving that problem of representing 3D space. And then there's like AI, this big giant thing, which is like almost everything going on in the gameplay in games. And what we're being asked to by this Photoshop of AI concept, what we're being asked to do is to find a single structure style decomposition that solves all these, right? So let's see, what structure style decomposition should I have that works for Scribblenauts and the NPCs in Madden football and the dynamic difficulty adjustment in Left 4 Dead? Like the single structure style decomposition that's going to solve those, so I can now just hand my handy like art tool to my behavior artists. When you put it that way, it's like, oh, that seems ridiculous. Of course there's not going to be a single tool that can do that. So maybe, so just to finish this point, if we think about graphics as representing Renaissance perspective, that basically, Renaissance artists figured out how to represent 3D objects in space on a 2D plane, right? Like that was the trick. It's really on 2D, and I have to figure out how to place little blobs of color on a 2D surface so that your brain gets tricked into perceiving it as 3D. And there's a lot of different ways you could take what your eye sees and map it into blobs of color on a plane. And so Renaissance artists kind of figured out how to map those blobs of color on there so that your brain got tricked into perceiving it as a 3D scene. So that was cool. And that invention of perspective was a powerful invention. And in a sense, 3D graphics is about teaching that trick to the computer. So the computer can do what the Renaissance artists figured out what to do. AI is about representing almost everything else. right? Everything that is, what emotions, decision making, um, the player's trajectory over time, common sense reasoning, the properties of objects, all of this other stuff that's not 3D space representation gets put in the AI bucket. So really, AI as a discipline is fundamentally concerned about making the computer represent things. And this is why knowledge representation is such a big core pillar in AI, because it's sort of the AI researchers that when some new domain comes up in the world that people want to represent in the computer, they're the ones who typically scratch their heads and say, God, how are we going to teach the computer about this now? And they have to invent some new representation. And game AI fundamentally underlies gameplay. The playable model, the underlying kind of playable simulation that supports the gameplay is AI. AI is gameplay code. AI technology is the key to deep interactivity, consequence, and meaning. So this is why what I call what I do expressive intelligence, in the expressive intelligence studio, for instance, as opposed to, say, expressive databases or expressive networking or expressive computational theory or all these other subfields, because intelligence, AI as a subfield, is the subfield that's concerned with representing meaning to the computer. So being asked to find a single structure style decomposition for AI is like being asked to come up with the single decomposition that works for representing all meaning of any kind. It's like, ugh, that doesn't sound very possible or plausible or desirable. Just a little advertisement for Noah's book. I know those of you who have taken interactive storytelling last year have a copy on your shelf. This is a great book to read if you're interested in this sort of history of kind of AI representations of meaning. And Noah particularly focuses on kind of the history of AI representations of narrative and characters and storytelling. But it provides in a very readable framework kind of a historical account of how AI developers go about thinking about how to represent new kinds of meaning to the computer. So it makes some of what I'm saying like super concrete. So maybe what we're going to have is photoshops of AI, right? Instead of the single structure style decomposition, we're going to have, well, there's one for Sims-like NPCs, and there's one for football NPCs, there's one for city simulation, and there's one for RTS strategy, and so forth. So we'll have a lot of photoshops. Each that kind of nails a structure style decomposition for a particular subproblem in AI. Okay, that sounds like a little more tractable, right? So now it's time to dive into the properties of what make Photoshop Photoshop, right? What's kind of seductive about this argument of having a Photoshop of AI is we all kind of hear Photoshop of AI. That's something artists can use, and they need to know anything about the technology, and they can make beautiful stuff that works in the computer, right? So the seduction is kind of that, oh, well, we need to have something that's the equivalent of that for controlling behavior. Something that you can just hand to anyone, that's easy to use, and allows you to represent it to the machine. So Chris gave a number of desiderata for style degrees of freedom. DOFs are style degrees of freedom. So if you're thinking about the style representation, like in the case of Photoshop, you want things that are intuitive, expressive, frugal, blendable, and efficient. Right? So it should be, in the case of like textures, a bitmap is a pretty intuitive representation of a texture. It's expressive. You can make any kind of texture you want. It's frugal. It doesn't make you represent a whole bunch of extra stuff that's above and beyond just the job you're trying to solve, which is the texture, right? You don't have to like sort of bend over backwards to represent the texture. You can represent it pretty directly. It's blendable. You can take several textures, and there's algorithms for kind of combining them together into new textures, and it's efficient. Great. So let's first ask if Photoshop itself for textures is intuitive and efficient. Right? So I was just I don't know. I assume how many people here have used Photoshop? Okay. And do you usually use Photoshop for loading in an image that's in one format and saving it in a different format? Sorry, it's the format conversion tool. All right. How many people here have done like sort of complex photo editing in Photoshop? A few people. Wow, actually a decent number of people. All right. So then I can ask you when I'm done with this slide whether you think it's intuitive and efficient. Here's the steps for changing hair color in Photoshop. If you wanted to change someone's hair color in a photograph. And I only go sort of 1/3 of the way through them. Open the image and click the Channels tab on the Layers palette. Duplicate the blue channel by right-clicking and choosing Duplicate Channel. Turn off the visibility of all channels other than blue by clicking on the eye icon. And there's a bunch of other stuff in that one step. Select the Dodge tool. Set the range as highlights and the exposure to 46%. 45 or 47, 46%. Now highlight the image other than the hair. Select the Burn tool. Set the range as shadows and the exposure to 100%. It goes on. We're about 1/3 of the way through the directions from sort of a how to use Photoshop manual for changing the hair color. So intuitive and efficient, I'm not feeling very intuitive about this at this point. So this is a couple-year-old book result. I just did an Amazon.com book search for books about Photoshop. And as of 2 years ago, there were 17,133 books. And these are these big, like, telephone books that you can use to crush things with, books about how to use Photoshop, of which between January and October 2009, another 1,602 had been published. So if you sort of look at that, this is feeling less and less like what it's been set up to be, which is the sort of intuitive and efficient thing anyone can just pick up and represent their style. Right? It's starting to sound like, oh, actually a rather complex professional tool that could take years to master, to actually be competent at creating complex and rich images. And even the pros routinely make errors. So here we got a cover of a magazine actually published. Oh my God, what happened with the fingers? 1, 2, 3, 4. 1, 2, 3, 4. Okay, so it looks like 4 on one hand with a thumb that's about as long as an index finger, and then 5 on the other that almost look normal, right? So this is an example, and there are blogs like Photoshop disasters that you can look at where pros end up doing things like this, right? Now it could be, given the source image, it was kind of the best they could do. I don't know how these kind of editing errors end up, but with crazy things like this happening and sites devoted to tracking down the errors that pros make when doing Photoshop editing, it's starting to feel less and less like the sort of intuitive and efficient tool that anyone can pick up and use, even just for authoring textures. And so now, if we're being asked to make a Photoshop of AI, and we do it for these sub-AIs, I guess it's starting to feel plausible to me if I'm allowed to publish 17,000 books about how to use the tool, and people have to go to art school for 4 years, but this would be like behavior school for 4 years before they're able to use it, right? Okay, now maybe I can believe we can start making a Photoshop of AI, but again, only for sub-problems. So you'd have to go to Sims AI art school, and then you would become the master of the Sims AI Photoshop, or to American football AI art school, and you become the master of that one. So we could say, well, this isn't fair because Photoshop might indeed be intuitive for trained visual artists. People who already are masters in using their master draftsmen or master painters, right? And that Photoshop is basically designed for someone who's really good at using those physical tools and using them in the computer. And so then maybe we'll change our restriction and say, okay, it doesn't have to be intuitive and easy to use for everybody, like walk-up easy to use, but it should be intuitive and easy to use for people trained in the traditional skill. So in this case, Photoshop is to traditional visual art, right? As well, we're trying to decide what a Photoshop of AI would be. So we have question mark, is to traditional interactive behavior authoring? Like who is our set of existing master craftspeople who are masters at creating behavior? And you could say, well, maybe screenwriters. Screenwriters create behavior that gets enacted on screen by actors, and they're specifying behavior in language in a screenplay. Maybe actors, but it's not. We look at those examples, and they're not nearly as clear and crisp as like visual art with a paper and pencil and visual art on the computer, right? So this Photoshop of AI thing is even tougher, even if we make it that we say that sort of experts who are already experts in the traditional form could use it. Well, we don't have any experts in the traditional form. We don't know what this thing would even look like, but we think we'd need a lot of them for all the different subtypes of game AI there are. So I do believe in this idea of the AI designer, a new type of artist. So Damian wasn't smearing my good name by attributing that position to me. He knew darn well that's pretty much what I believe. And that we don't have existing artists yet who are craftspeople at creating interactive behavior, and that we're basically seeing the birth of a new art discipline as we move into the 21st century with the creation of complex interactive artworks, right? And games are complex interactive artworks. So here, a number of people have seen me use this example. I love it because it's an early robotic sculpture built by Ed and Notowitz in the late 60s. And it's called the Senster. And if you Google the Senster, you can find some videos have been unearthed of it in action. And it engaged in these beautiful sort of slow animal activities, and the head would crane forward, and then people would make a loud noise, and it would kind of recoil, and then get curious, and then sort of sniff up to the person and turn its head to someone standing to their side. And it really gave this very rich appearance of being a living creature, right? And he built this in 1969, controlled by computers of the time. Writing in assembly language, having, before there are any like standard robotics parts. And he wrote sort of a manifesto where he talked about the aesthetics of behavior, where he said that, he felt like there was a new art form coming into a being that was about figuring out what aesthetic effects different physical behaviors and representations of physical behaviors have on an audience over time. And so this was his stab at doing that. That's cool. That's the AI designer. That's a behavior artist. So but this makes our job harder because there's no pre-existing representational schema for us to be intuitive to. There's nothing like the visual artist that's this representational schema that we can then say, okay, let's try to make our art tool look like what they already do. We don't get that benefit. So Photoshop does not equal ease of use. If we set Photoshop as our benchmark for accessibility, then we can require long training periods and thousands of pages of documentation. But to make matters worse, there won't even be just one authoring tool. So now let's move on to the third point I wanted to make about Photoshop AI, which is about conditional execution and style. So the essence of AI is that it's a conditional process executing over time. That it actually does different things depending on how the player interacts with it. So the style of such a process actually lies in its conditional decision making. What makes a particular NPC feel like a particular NPC is how it makes decisions over time compared to how some other NPC makes decisions over time, right? Or what makes a particular director, AI director that's doing dynamic difficulty adjustment feel different from a different AI director is the details of how it makes different decisions over time. This is really different from the static nature of the triangle texture decomposition, right? We have a static triangle, we have a static texture, so I map a static thing onto a static thing, and so the style's a static thing, and the structure's a static thing. Here, style is actually is the result of a dynamic process. And this is going to make it, again, much harder to think about a Photoshop-like tool. This came up, so this is a screenshot from Spore Galactic Adventures, which was a follow-on to Spore. I don't think Kate's here today. Don't see her, but Kate Compton, one of our PhD students, worked at Maxis for years and was one of the people who worked on Spore Galactic Adventures. In fact, this cockroach world based on Kafka, Kafka's Metamorphosis, was an example world she created. So what Spore Galactic Adventures wanted to do was to do for adventure authoring what the Spore Creature Creator did for creatures, right? So the Spore Creature Creator let sort of anybody come in and with very little training make stuff that looked good. right? And that was what was really cool about the Spore Creature Creator, is that they found a way to constrain the authoring process so that sort of almost no matter what you did, you got something that looked good, that was implicitly obeying certain artistic rules. And that was a really cool and interesting, clever trick. Because if you compare Spore Creature Creator to 3ds Max, for example, 3ds Max just says, here's the entire space of all possible 3D models. If you don't know anything about making 3D models and you come in and noodle with it, you mostly make a bunch of garbage, right? But Spore Creature Creator says, I give you the feeling of kind of this large space of 3D models, but actually we've carefully isolated that space of models. So there's only a few parameters you can adjust, those draggable things, and everything you can basically do within that space of draggable things looks reasonable. So that was a really interesting example of, and Chaim Gingold, who worked on Spore Creature Creator, who's also here at Santa Cruz, he was basically the lead design behind the Creature Creator. He calls that kind of a thing magic crayons. And so I think magic crayons is like an even better metaphor than Photoshop, right? And so Spore Creature Creator really is magic crayons. It goes much further than Photoshop, and anyone can walk up and use it and make things that look good because they've carefully constrained the tool. Well, they wanted to do that now for adventures, so that you've got your giant universe of planets that you can go down to any one planet, and other players will have authored adventures that then get sort of crowdsourced onto your planets, right? So that when you go down to planets, there's actually cool and interesting things to do. This turned out to be a much harder problem than making the Spore Creature Creator work. And the problem was exactly conditional execution, right? That if I'm making a little adventure and I have a particular NPC who has to walk up and give me an object at a particular time, well, the detail, like whether that NPC is going to make it or not, depends on a lot of complex details of pathing, how you've dynamically changed the world, that you can't just sort of make a change in your adventure and immediately see that that makes the adventure better or worse, in the same way that you can make a change in this Creature Creator and immediately see that it makes it better or worse, right? The only way to do it is you make changes and then you have to run it and play through it, right? And then you make changes and you have to run and play through it again. That's because in an adventure, there's a lot of conditional execution going on. In a creature, there isn't. It's basically a static object. So static artifacts support this immediate global feedback, right? So we have someone here working in Photoshop with their Photoshop-like tool, and they decide to apply posterize to the image, and it goes, bring, there, it's posterized. And they can sort of immediately apply that, get this immediate global feedback, right? They can see what the whole image looks like immediately, and how that changes it stylistically from the application of that. Rapid feedback in authoring AI is a lot harder. And in fact, in general, that kind of immediate and global feedback is impossible due to Mr. Turing. So I guess we should say Dr. Turing, appropriate deference. So Alan Turing proved that the halting problem is not solvable by a computer, that there exists no algorithm in the space of all possible algorithms. So, sort of like, in God's mind and all the algorithms God can think up, there isn't one that solves the halting problem. So that's kind of, but it's a completely well-defined problem. So that was kind of a shocking thing, that you'd think a completely well-defined problem should be solvable by some algorithm you could write in the computer, because computers are great at completely well-defined things. No, there exists this particular problem, which is, given an arbitrary computer, figure out whether it ever stops or not, the program it's running. That there's in general no way to do that. And you think, oh, well, that sounds like some really esoteric thing that maybe matters to mathematicians, but who cares? Like, he basically came up with this sort of like dirty trick of a problem, basically, that you could prove, because it's kind of meta and recursive and all that, that he could prove a computer couldn't solve. Well, the problem is that many, many interesting properties that we might want to ask about programs, if you had like the magic IDE and you could ask your IDE questions about, is my program ever going to get here? Will this variable ever get set to the wrong value? Well, most of those are mappable to the halting problem, which means that in general, computers can't tell you automatically, in some immediate and quick way, what another program is going to do. So if you have your behavior AI authoring tool, and you're basically authoring conditional code under the hood, right? Even if it doesn't look like code to you in your AI authoring tool, that's what you're doing. There is no general way for that AI authoring tool to look at that thing and say, oh, with this change you've just made, you're never going to get to this part. Or, oh, with this change you've just made, the character is going to see this pattern over time, right? I mean, the player is going to see this pattern over time. There's no way to answer those questions in general, other than just like running the program. So this kind of immediate feedback thing that you can get with a static artifact like Photoshop, you sort of in principle can't do with an artifact like a program. And AI is inherently program-like, not static object-like. Now, that's not to say that that there aren't really cool things you can do with what are called static analysis. And in fact, I think that's a direction that game authoring tools should go. And we've done some of that in our lab, in fact, to build programs that do their best to try to answer, to statically answer by looking at a program questions about properties of that program from a game perspective. Right? And the halting problem doesn't say you can't do that in particular cases. It just says you can't do it in general. And so, but particular cases can still be very useful. So I do want to say that I actually think that kind of, doing the equivalent of this, where you get the immediate feedback for AI code, for game AI, is actually a really cool research problem. But you just have to keep in mind you're never going to be able to solve it in general. You'll solve it in specific cases. So this implicit idea of talking about kind of when Chris was talking about the stylistic degrees of freedom and they're blendable and they're frugal and all these properties, it's clear that he's thinking about the stylistic degrees of freedoms as numbers, right? And all of his examples are numbers, right? A bitmap is a bunch of numbers, frames of animation data are a bunch of numbers, waveforms are a bunch of numbers, points specifying Bezier curves are a bunch of numbers. And so we're kind of envisioning the static number data and all the blendability and immediate feedback and all that is basically done by performing math operations, numeric math operations on numbers. And he explicitly called out code as not being appropriate, right? Because code is not intuitive in the same way that he would claim a bunch of numbers is, and it's not blendable in general. Like taking this piece of code, here's a piece of C code I wrote, and here's a piece of, here's a separate C function I wrote. Combine them together into a new function that does something useful, right? That's not something we really can do with code, but you can do that with two textures, for instance. But the problem with this is it's really continuing a tradition in game AI of being anti-symbolic, of kind of viewing that what computers are fundamentally about is manipulating numbers, right? And this is the view of the computer as a big calculator. But the computer is not a calculator. The computer is a general purpose symbol manipulator. And this was very clearly recognized by early computer pioneers in the 50s, that what computation is really about is arbitrary manipulation of symbolic structures. And one of those kinds of structures happens to be numbers, right? But that's what, in almost the whole history of AI has been about representing all the things to the computer that are hard to represent just as numbers. Right, and finding symbolic representations for them. And if AI inherently has this conditional execution property, which I claim it does, then it is going to be code-like. That AI is fundamentally going to have this code-like property of not being a bunch of numbers, but actually being a little machine, right? A little machine that runs and does something. And so you're really authoring little machines. And in fact, there are ways to author little machines so that they do blend together, right? You have to work at it, but in Facade, for example, an interactive drama I worked on with Andrew Stern a few years ago, one of the big technical pushes we made in the underlying AI was to support behavior blending. And the idea of behavior blending is basically to say, I've got these symbolic behaviors, and I want to be able to author like two symbolic behaviors. And if a character happens to run both at the same time, I want them to do something sensible. And at sort of 3 different levels in that architecture, at both the sort of beat sequencing level, the dramatic goals being pursued within a beat. Dramatic beats are sort of little units of dramatic action. And in the details of how those actions were actually carried out and how we listen for player interactivity. This kind of decomposition that we came up with, so this is an example of a decomposition. Wouldn't really call it a structure style decomposition, but it's a breaking up of the problem of making fancy NPCs you can talk to into 3 separate subsystems. Those subsystems explicitly supported were developed to have behavior blending. And so, but this is a solution, like this solution isn't particularly useful for Madden football, right? And this solution isn't particularly useful for Scribblenauts and making like a better common sense reasoning based game. It's a solution that's specific to conversational characters. And this strategy of kind of building custom machines, you can kind of view these 3 layers as kind of 3 different layers of like custom virtual machine. They each have their own language. You describe beats, you describe beat behaviors, you describe handlers and what we call mix-ins, all in their own kind of custom languages, and then those custom languages know how to execute and combine things together. This is a standard practice in what's called knowledge-based AI. And in fact, it's a rather classical approach, right? So in classical AI, the approach to solving a problem is to create a custom knowledge representation language. Basically, think of it as a custom programming language that is designed specifically to make solving your problem as easy as possible. Then you write your easy program in your custom language, and boom, you've solved the problem, right? And that sort of custom language approach is all about leveraging the machine, the computer, as a symbol manipulator. So this is kind of related to the idea of scripting, but far more general than scripting. Scripting languages tend to, at least game scripting languages, tend to all expose the same C-like imperative programming paradigm. And what the scripting language is doing is basically giving you C-like access to a bunch of game engine internals. But as a language, the differences between Unreal Script versus some other scripting language, well, they're basically all C-like languages giving you custom API access. This approach is about creating languages that don't look anything like C at all and don't execute like C at all, but are really targeted to do a specific kind of custom symbol manipulation. And once we start thinking this way, it can kind of get us out of this rut of that game programming has to be about a bunch of numbers and doing math operations on numbers. And this stylistic degrees of freedom position that Chris is taking really is coming from this like number-centric point of view of programming. And AI is just not amenable to that number-centric point of view because it's conditional execution. However, I completely agree with Chris that game AI must be authorable, right? That game AI is content. But that doesn't mean that there's a universal solution. There's no universal solution that works for all AIs. There's no magic numbers and flags only representation, where just by specifying a bunch of numbers, I like magically make this NPC behave really differently from this NPC. Like the only way that would work is I would have to pre-author all the behaviors anyways in something that's not numbers, and then use the numbers to select between them. But that's just sort of deferring the problem, right? Someone still had to write all those behaviors that the numbers are used to select among. And there's no pre-existing artistic tradition we can leverage. There's nothing like the equivalent of visual art with paper and pencil or paint and canvas that we can build from. We're having to create it from scratch. This idea of sort of AI art and creating AI artists. So given kind of operating in this sort of vacuum, how do you know if what you're doing is any good? Right? Like, it's like, how do I know if I'm making any progress in doing cool stuff in game AI if, like, I can't pursue any of these things? Well, one way to think about whether you're making progress is to think about the concept of authorial leverage. This is something we've worked on a bit in the Expressive Intelligence Studio here, which is, and this is just kind of a concept equation, not a real math equation, though we've found ways to try to operationalize it. But the idea behind authorial leverage is that for a given quality of experience, a given quality of behavior, and a given number of ways that that behavior can vary over time. If you can create that with less effort, you get more leverage. Right? So it's sort of, if I want to have a bunch of different ways a conversation can carry out, but I have to author all the different ways the conversations can go out manually, all the different branches manually, that would be an example of low leverage, because I would have high variability on the top, but I would have high effort on the bottom, and they would sort of cancel each other out. But if I can get like a large amount of ways a conversation can carry out for much less effort, on the bottom of this, than manually authoring all of them, then the AI is actually giving me leverage. And so what we've done is we've kind of used this equation as a way to compare for given AI systems, whether doing it our sort of fancy AI architecture way is easier than manually specifying it. So for example, for story management and interactive storytelling, we've compared story managers we've come up with against script and trigger approaches, where script and trigger approaches are the standard way of just pre-specifying, when the player gets here and their health is below this, then you trigger this story event, else you trigger this different story event. That's the manual way of specifying it. And we have found that, yes, indeed, we can develop AI architectures that, for much less effort, give you the same amount of variability as some hand-authored thing. And so, hooray, the AI is giving us leverage. So that's really kind of an authorship-centric way forward for thinking about game AI, is to focus on the author, to focus on what the author has to change in order to create the experience, and to try to create AIs that give that author as much leverage as possible, as much bang for the buck for every action they have to take, or every authorial action they have to take. So, in Sims 3, we could apply this into thinking about Sims 3, that, we have some complex social situation going on. A lot of people are moving around, talking to each other, different animations are playing, and we can sort of ask, like, what stuff did the Sims 3 authors have to author within their AI to create all of these different kind of social scenarios that can come up? And was that less work than if they had just pre-authored a bunch of different social scenarios? And the answer is yes. It's less work. They definitely got leverage. What they had to author were things that they called social practices. The Sims 3 Sims know how to do things like go to bed, answer the door, these little kind of practices you do in everyday life. They know how to query objects to find out what verbs are available on them. And there's a bunch of rules for determining kind of which social practices Sims want to do next in different situations. So that's the stuff they had to author. And they also had to author a huge amount of animation, right? So the most heavyweight kind of brute force thing they had to do in The Sims is create a ton of high quality animations for like every possible action in the game. So that's the part that's actually kind of dragging down their leverage a bit, is the AI is kind of more generative than the animation system can actually express. But given those pieces that they had to author, that's still much less work than having to pre-author like all possible combinations of how Sims can interact with each other. So that would be a concrete example from a commercial game of game AI, in this case Richard Evans' AI, providing leverage. So to summarize, Photoshop of AI, a mirage. However, that doesn't mean that we stop thinking about AI authoring, but that we need to sort of roll up our sleeves and start thinking about realistic forms of AI authoring for specific concrete experiences, rather than trying to come up with sort of universal killer solutions. Thanks.